I am Ivan Michael C. Atienza of Batangas State University, Bachelor of Science Information Technology. For this video, I'll be doing the Chapter 6 summary. The title of this chapter is Network Layer. So this is a CCNA 1, Routing and Switching. Let's start. Chapter 6, Sections and Objectives. Chapter 6, 1. Network Layer Protocols. Describe the purpose of the network layer in data communication. Explain why IPv4 protocol requires other layers to provide reliability. Role of major header fields in IPv4 and IPv6 packets. Routing. Explain how a lost device uses routing tables to direct packets to itself, a local destination or default gateway. Compare a host routing table to a routing table in a router. Routers. Common components of interfaces of a router. Boot-up process of Cisco iOS router. Configure a Cisco router. Initial settings on a Cisco iOS router. To active interface in Cisco iOS router. Devices to use a default gateway. Network layer protocols. Network layer in communications. The network layer end-to-end transport processes, addressing end devices, encapsulation, routing, encapsulation. Two network layer protocols are IPv4 and IPv6. Network layer protocols is how the exchange of data happens. Network layer protocols. Characteristics of IP protocol. Encapsulating IP. Segments are encapsulated into IP packets for transmission. Network layer adds a header so packets can be routed to the destination. IP connectionless. Sender doesn't know if the receiver is listening or the message arrived on time. Receiver doesn't know data is coming. IP best effort delivery. No guarantees of deliveries are made. Media independent. IP can travel over different types of media. Network layer protocols. So this is a network layer PDU of the IP packet. Transport layer encapsulation. Network layer encapsulation. Network layer as a header so packets can be routed through complex networks and reach their destination. In TCP, IP-based networks, the network layer PDU is IP packet. Network layer protocols, IPv4 packet. IPv4 packet header. So this is the IPv4 packet header. Network layer protocols, version is equals to 0100. DS is equals to packet priority. ETL means limits life of packet. Protocol, upper layer protocols such as TCP. Source IP address is equals to source of packet. Destination IP address, the destination of the packet. Network layer protocols, IPv6 packet. Limitations of IPv4. IP address depletion. Internet routing table expansion. Lack of end-to-end connectivity. IPv6. Increased address space. Improved packet handling. Eliminates the need for NAT. Encapsulating IPv6. Simplified header format. No checksum process requirement. More efficient options. Header mechanism. Flow label field makes it more efficient. IPv6 packet header. Network layer protocols. So this is IPv6 packet header. Version is equals to 0110. Traffic class, priority, flow label, same flow will receive same handling. Payload length, same as total length. Next header is equals to layer 4 protocol. Top limit replaces TTL field. Routing, how a host routes. Host forwarding decision, three types of destination itself, local host, remote host, default gateway, routes traffic to other networks, has a local IP address, the same address range as other hosts on the network. Take data in and forward data out using the default gateway. Hosts will use the default gateway when sending packets to remote networks. Host routing tables use the nestat -r command to display the host routing table on the Windows machine. This is an example of routing IPv4 routing table for PC. Routing host host routers. How the host routes router routing tables. Router packet forwarding decision. Routers and hosts forward packets in a similar fashion. The main difference is that routers have more interfaces while hosts often have only one. Devices on directly connected networks can be reached directly. Devices on remote networks are reached through gateway. IPv4 router routing table. Router routing table routes network routes the router knows about. Use the show IP route command to display the routing table in the Cisco router. The router routing table also has information on how the route was learned, its trustworthiness and rating. It also contains which interface to use to reach the specific destination. Directly connected routing table entries. C identifies the directly connected networks, automatically created when an interface is configured with an IP address and activated. L identifies that is the local interface. This is the IPv4 address on the interface on the router. Remote network routing table entries. Remote destination can be reached directly. So this is the routing IPv4 routing table. This is an example of routing in the IPv4 routing table. Routers. Anatomy of a router. A router is a computer. Routers have CPU, memory, and I/O devices. Cisco routers uses iOS as their operating system. Router memory. Just as a computer, routers have memory. Routers contain RAM, ROM, and VRAM and flash memory. Inside the router, routers have the same general structure. Connect to a router. Routers have ports and support connections. LAN and WAN interfaces. Routers have LAN and WAN ports. Different models ship with different ports. Ethernet is very common in different router models. So this is an example of the inside of a router, a Cisco router. Bootset files. iOS image file stored in a flash contains the iOS. Flash also stores the system files, and VRAM stores configuration parameters. Router boot up process. Perform the post and load bootstrap program. Locate and load the Cisco iOS software. Locate the load startup configuration file and enter setup mode. Show version output. The show version command is very useful. It provides information on amounts of memory installed, what iOS images was loaded during the boot, and more. Configuring our Cisco router. Configure initial settings. Basic switch configuration steps. Configure device name. Secure exec mode. Secure VTY lines. Secure privilege exit mode. Secure all passwords. Provide legal notification. Configure the management SBI. Save the configuration. Basic router configuration. Steps. Configure device name. Secure exec mode. Secure VTY lines. Secure privilege exec mode. Secure all passwords. Provide legal notification. Configure the management SBI. Save the configuration. Configuring a Cisco router. It's an example of that. Configure a router interface. Enter the interface sub-configuration mode. Add a description to the interface. Configure IPv4 IPv6 address. Activate the interface and no shutdown command. Verify interface configuration. Show IP route. Show interfaces. Show IP interface. So this is an example of configuring a Cisco router. Default gateway for our host. Pinging a local host, this is how it works. So pinging a remote host, this is how it works. Configuring a Cisco router. This is another example of configuring a Cisco router. Default gateway for a switch A. Default gateway is required for remote network communication. If a switch is to be managed via SBTY lines, it needs a default gateway. Use the IP default gateway command to configure the default gateway for a switch. So that's all for my chapter 6 summary, and thanks for watching.